We will use calculus to prove the surface area formula of a sphere. We will define the shape, set up the integration using the arc length differential, and find the area. We start with a semicircle defined by the equation x squared plus y squared equals r squared. We revolve this semicircle around the x-axis to create the three-dimensional sphere. To calculate the area, we divide the curved edge into many tiny segments of length ds. When this small segment revolves, it forms an infinitesimal circular band around the axis. The surface area of this tiny band, called dAAY, is its circumference times its length. This band area is defined by the formula dAAY equals 2 pi y times ds. Next, we must define the differential length ds using calculus and the derivative y prime. The arc length differential ds is the square root of 1 plus y prime squared, multiplied by dx. Now we must solve our circle equation for y and then find its derivative, y prime. Solving for y gives us the square root of r squared minus x squared. Finding the derivative y prime gives us negative x divided by y. We substitute both y and y prime into the arc length differential formula for ds. This substitution makes the resulting integral solvable using standard techniques. To find the total surface area A, we integrate 2 pi y ds from x equals negative r to x equals r. After performing the integration, we find that the total surface area A equals 4 pi r squared. The surface of revolution method gives us the known geometric result exactly. To reflect on this area formula, let us check it against the sphere volume formula. If we differentiate the sphere volume, which is 4/3 pi r cubed, we get 4 pi r squared, which is the surface area A. This match confirms that our calculus derivation of the surface area is correct. We successfully derived the surface area of 4 pi r squared by revolving a semicircle and integrating its parts using ds. We can use the power of calculus to verify and prove complex geometric formulas that describe the world around us. Generate your own educational videos for free at eduvids.vercel.app.